Concept A is I can determine the cross sections of a three-dimensional solid and what actions can be used to create a solid. So number one, it's just naming a figure. So these are both cylinders, but there is one distinct difference between the two. If you notice, the one on the left is standing upright, the one on the right is kind of slanted. So the word that we use to differentiate between the two is a right versus oblique. So on the left, this would be a right cylinder, because the height makes a right angle with the ground. The figure on the right, we would say it is an oblique cylinder because it's irregularly shaped. It's kind of slanted. All right, number two, this is talking about different actions and what figures they can create. So it is helpful to maybe draw a picture. So for A, we're stacking congruent circles. So if we stack congruent circles, that forms a cylinder. Similar circles means the figures get smaller and smaller and smaller, which results in a cone. Stacking congruent squares that would make a rectangular prism or a cube. But remember, we can always call anything a rectangular prism. A cube is special because it's equal on all sides. Stacking similar squares, so that means the squares get smaller and smaller and smaller, which means they come to a point, which would make a square-based pyramid. Similar rectangles is the same idea, but in this case, instead of a square base pyramid, it would make a rectangular base pyramid. And we didn't really talk about this figure, but we should still know what shape it would form. Okay, if we translate a circle, that's basically like taking it here and translating it up, that would make a cylinder. Translating a rectangle, again, looks something like that. That would be a rectangular prism. Translating a triangle would be a triangular prism. And these all make prisms, which should make sense since we translate the base, it would form two bases. And remember that prisms are shapes with two bases. So cylinder, rectangular prism, triangular prism all have two bases. All right, the next one is rotating a circle. So that's if we take a circle like this and it rotates around, it would make a sphere. Rotating a triangle, and this gets turned around, it would form a cone. And then rotating a rectangle would form a cylinder. So you see how sketching a picture of the action that is happening does help you kind of see what shape it's forming. All right, the next one says list two actions that create the same solid. So really what we can do is we can just look at the actions above and list two, but the example that I give would be stacking similar circles and rotating a triangle both creates a cone. So if we take a shape, say for instance a cylinder, there's a few different ways we can form a cylinder. We can stack congruent circles. There's actually three ways we can form a cylinder. We can stack congruent circles, we can rotate a rectangle, and we can translate a circle. And all of these actions create a cylinder. When we're describing an action, we do need to be specific about what we are stacking. So we're stacking congruent circles. We are rotating a rectangle. We are translating a circle. All right, so now we're going to talk about cross sections. So parallel to a base of a cylinder. So if I draw a cylinder here and I cut parallel to the base like this, and we open up the shape, that's going to be a circle. Perpendicular to the base, perpendicular, we would be cutting it in this direction. That would make a rectangle. A square pyramid looks something like this. So parallel to the base would be cutting like this, and if we open it up and looked at that, it would be a square. And then perpendicular, we would cut it this way, that would be a triangle. And then for a cone, parallel to the base would look like this, that would be a circle. And then perpendicular, we would cut this way, that would be a triangle. So one thing that might help you for the cross-section problems is remember that anytime we are cutting parallel to the base, the cross-section is the same shape as the base. So for instance, a cylinder, we cut parallel to the base. The base of a cylinder is a circle. The cross-section parallel to the base would be a circle. For a square-based pyramid, the base is a square. If I cut parallel, the cross-section is a square. Same thing with a cone. The base is a circle, cross-section parallel. The cross-section would be a circle. All right, number 5 says draw a triangle below. So something like this. And then you're going to translate it diagonally to create another triangle. And then we're going to connect the vertices of the figure. The vertices are just the points. The solid that we create when we translate a rectangle is translate a triangle is a triangular prism. Okay, number 6 is asking to do something similar. We're drawing a rectangle, and we're going to translate it diagonally. And then just like before, we're going to connect the vertices. This would make a rectangular prism. And remember, anytime you're translating, you're basically copying and pasting the base, which results in two bases, which we know are prisms. So anytime we're translating, we're copying and pasting the base, and we end up with a prism. All right, looking at the next concept. So concept B says I can calculate the volume of solids that have triangular or rectangular bases. So in these problems, we're only looking at triangular based figures and rectangular based figures. So number 7 says a rectangular tank has a length of 15 feet, width of 8, and height of 9 feet. So I'm just going to sketch my rectangular prism. Looks something like this. So it's a fish tank, so it has a length of 15, a width of 8, and a height of 9. And then we know that water is filling the tank at a rate of 2 cubic feet per minute. We want to know how long it's going to take to fill the tank without overflowing it. So first thing we're going to do is we're going to find the volume of the tank. So we're just going to multiply 9 times 8 times 15, which is how you find the volume of a rectangular prism, and that's going to be 1080. And then what we're going to do is we're going to divide by the rate. That's going to give us how long it's going to take. So 1080 divided by 2 is 540. So the tank takes 540 minutes to fill. All right, number 8. So this is a triangular prism. And the way we find the volume of a triangular prism, it's 1/2 base times height times the height of the prism. So the base of the triangle is 13, the height of the triangle is 11, and the height of the prism is 15. So we're just going to plug that into the formula. It's 1/2 13 times 11 times 15. And when we multiply that out, the other way you could think of it is you could just do 13 times 11 times 15 divided by 2. You should get 1072.5 feet cubed. Don't forget your units on these problems. All right, number 9 says find the volume of a pyramid with a height of 14 meters and a square base with side lengths of 8 meters. So I'm going to draw my pyramid. And your pictures really don't have to be perfect. They just have to be good enough for you to know what you're calculating. Okay, the height is 14 meters. And the length of each side of the base is 8. So this is a pyramid, and the way we find the volume of the pyramid is length times width times height divided by 3, since it's a pyramid. So this is length, this is width, and then this is height. So it's going to be 8 times 14 divided by 3. So when we multiply, you get 298.67 meters cubed. All right, the next problem, it says a composite solid is made up of a square prism with a square pyramid connected on top. So I'm going to sketch a picture of this. So the bottom is a square prism, which basically just means a rectangular prism with a square base. And on top is a pyramid, like so. It kind of looks like a house. So then it gives us the dimensions. The base of the prism has side lengths 9 meters. And the height of the square prism is 12 meters. And then we're given the height of the pyramid is 6 meters. We're going to find the total volume of the composite solid. So starting with the top, or I'll start with the volume of the prism. Since it's a rectangular prism, we're just going to do 9 times 9 times 12. So 9 times 9 times 12 is 972. And then we're going to find the volume of the pyramid. And the base has the same measurement, so it's going to be 9 times 9. The height of the pyramid is 6, but since it's a pyramid, we're going to divide by 3. So that total volume is going to be 162. And now to find the total volume, in this case, it's a composite figure, which means we can add or subtract. So in this case, we are going to add, since it's just a figure sitting top of another figure. The only time we subtract is when it is another figure is inside of another one. So we're just going to do 972 plus 162, which is 1,034 meters cubed. All right, the next problem says a rectangular prism is shown below. Draw and label different size rectangular prism that has different dimensions but the same volume as a provided prism. So first thing we need to do is figure out the volume of this prism. So we're going to do 8 times 3 times 5. So 8 times 3 times 5 is 120. So what we need to do is we need to figure out a rectangular prism with different dimensions, but that still have a volume of 120. So the easiest way to do this is to make a factor tree, and you can just basically break down 120 to 3 factors. So for instance, when I see 120, I think 12 times 10. And then what you can do is you can just choose one of these numbers to break down further. So I could break down 12 to 3 times 4. And once you do that, now we have 3 numbers that multiply to make 120 that we can use as our dimensions for our rectangular prism. So drawing this rectangular prism looks something like this. Again, doesn't really have to be perfect. And we just need to label. So 3 by 4 by 10. And to verify it has the same volume, we're just going to multiply 3 times 4 times 10, which is 120 inches cubed. So if we needed to, we could even figure out another combination, but instead of maybe breaking down the 12, we could have broken down the 10 to 2 times 5. So 12 times 2 times 5 would be another combination that would work for a rectangular prism. All right, now let's look at the final concept, which is I can calculate the volume of solids involving circles. So these are all the shapes involving circles. So number 12 says determine the diameter of a cylinder with a height of 9 feet and a volume of 1,296 pi feet cubed. So this is a working backwards problem. The reason I know that is because we're starting with the volume. The way we find the volume of a cylinder is pi r squared times the height. So in this problem we're given the volume, so we're going to plug that in for the volume, and we are given the height, so we're going to plug that in for the height. So what we end up getting is 1,296 pi equals pi r squared times 9. Well, remember, when there's pi on both sides, we can basically divide by pi, which cancels it out on both sides. And then it's just a matter of isolating your radius. So we're going to divide both sides by 9 to get r by itself. So 1,296 divided by 9 is 144. And the last step, we do need to take the square root of both sides to get r by itself. So the radius is 12. However, we're asking for the diameter, so we're just going to multiply by 2. So the diameter of the cylinder is 24 feet. All right, number 13, it says the figure below displays a wooden cone with a cone-shaped hole, which is the darker shade. The diameter of the wooden cone is 16 millimeters and has a height of 16 millimeters, and the hole has a diameter of 6 millimeters and a height of 8 millimeters. We're going to find the total volume of the wooden cone. So this is a composite figure, but it is made up of 2 cones. So first thing we're going to do is we're going to find the volume of the bigger cone. And the way we find the volume of the big cone is pi r squared. So the radius of the big one is 8. So 8 squared times the height, 16. And since it's a cone, we're going to divide by 3. So 8 squared times 16 divided by 3. For the big cone, we get 341.33 pi. And then we're going to find the volume of the small cone, which is going to be pi r squared. So the radius of the small one, if the diameter is 6, that means the radius is 3. So pi times 3 squared times the height, which is 8, and again divided by 3. So 3 squared times 8 divided by 3. So the volume of the small cone is going to be 24 pi. So now to find the total volume, in this case it's a composite figure, which means we can either add or subtract, but since it's a figure inside of another figure, we are going to subtract these 2 volumes. So 341.33 pi minus 24 pi. So 341.33 minus 24 is 317.33 pi. So I left these both in terms of pi because the shape, both parts of the shape involved a circular shape, which is why we can leave it in terms of pi, but we do need to get our approximate answer. So we're going to do 317.33 times 3.14, which gives us about 996.42 millimeters cubed. All right, the next one is another composite figure, but it is only made up of cylinders. It says find the volume of the 3-tiered cake. So it gives us the dimensions. So for each one, we're just going to find the volume. So starting with the top, it's pi times the radius squared times the height, and we're not going to divide by anything since it's a cylinder. So this is 16 pi. Then I'm going to find the volume of the middle, which is pi times 4 squared times 4, which is 64 pi. And then finally the bottom shape is pi times 8 squared times 4. So 8 squared is 64, 64 times 4 is 256 pi. So now I have my 3 volumes. And in this case, since the shapes are sitting on top of each other, to find the total volume, we're going to add. So 16 pi plus 64 pi plus 256 pi. So the total volume is going to be 336 pi inches cubed. Then to get our approximate, we're going to do 336 times 3.14, which is 1055.04 pi, or not, sorry, not pi, 0.04 inches cubed. So your answer in terms of pi is always going to be a smaller number, and then when you multiply by 3.14, it is going to be a bigger number. All right, number 15 says Sandra is cooking tofu meatballs for a special spaghetti dish. She wants to experiment with the size of meatballs and how it will impact their flavor, texture, and cook time. She will create a meatball with a radius of 1.5 millimeters, another with a radius of 2, and last with a radius of 2.5. Sorry, my dog's just crashed into something. All right, so now to find the volume of each one, and then we're going to add it together. So starting with the first one, it's a sphere, so the formula is 4 pi times the radius cubed divided by 3. The second one is going to be 4 pi times 2 cubed divided by 3. And the third one is going to be 4 pi times 2.5 cubed divided by 3. So with the first one, 4 times 1.5 cubed divided by 3, we get 4.5 pi. And again, since they're all shapes involving pi, I'm just going to leave it in terms of pi. Then we have 4 times 2 cubed divided by 3. That's 10.67 pi. And then the last one, 4 times 2.5 cubed divided by 3 is 20.83 pi. So now to find the total volume, we are going to add these 3 together, just like we did in the previous one. So 4.5 plus 10.67 plus 20.83, we get 36 pi millimeters cubed. So there's my answer in terms of pi. And then we're going to multiply by 3.14 to get my approximate, which is 113.04 millimeters cubed. All right, the last problem, it says Charlene has half a can of paint left. The can has a radius of 2 inches, so something like this. The radius is 2 inches and it's half full. So she takes the remaining paint and fills up a hemisphere-shaped bowl, so that's just the shape half of a sphere, with a radius of 3 inches. What is the height of the paint can? So what we know is that the volume of the paint here equals the volume of the paint in the hemisphere. So first we need to find the volume of the hemisphere, and then we can work backwards to find the height of the can. So starting with the hemisphere, the volume is going to be 4 pi times the radius cubed divided by 3. Which is 4 times 3 cubed divided by 3 is 36 pi. But since it's a hemisphere, we're going to divide that by 2. And it's going to give us 18 pi. So that tells me that the volume of the paint in this can is 18 pi. So now we can work backwards. To figure out what is the height of the paint in the can, we're going to work backwards. So 18 pi equals pi times my radius squared times the height. And remember, this is just going to give us the height of the paint. We want to know the height of the can, so we would just double that. So first, starting with the height of the paint, we're going to cancel out the pi's. So we have 18, 2 squared is 4. Then we're going to divide both sides by 4. So 18 divided by 4 is 4.5. So this is how much the paint is. Since we know the can is half full, we're just going to do 4.5 times 2, and that's going to give me the total height of the can, which is 9. So this is going to be, the height would be 9 inches.